Okay, this will be the BC Calculus sample questions 5 and 6. And question number 5, it's basically just an integral, and they want you to integrate x over x squared plus 5x plus 6. So this is just going to be a good old partial fractions problem. So remember, we have to do our partial fraction decomposition on this rational function. The denominator, x squared plus 5x plus 6, that just factors as x plus 2 times x plus 3. Remember, we break it up so that each factor gets its own fraction. And then on top, we just have to put constants, a and b. And then again, our goal is simply to solve for that. So I'm going to go through partial fractions a little faster. I assume if you're watching this video that you've seen partial fractions before. So I'm going to multiply both sides by the denominator, x plus 2, x plus 3. Well, if I do it to the left, I got to do it to the right, x plus 2, x plus 3. On the left side, everything cancels out. I'm just left with x. On the right side, when I distribute, the x plus 2's will cancel out, so I'll have a times x plus 3. And then I'll have b, and then when I multiply out, the x plus 3's will cancel, so I'll have b times x plus 2. We could do equating coefficients and all that, but again, there's a little trick where what you try to do is pick clever values of x that will either make the a term disappear or the b term disappear. So notice if I let x equal negative 3, well, I have to plug it in everywhere in my equation. So if I plug in negative 3, well, I'll get negative 3 on the left. Notice if I plug negative 3 into the first part, I'll get a times 0, so that just cancels out. And then we'll get b times negative 3 plus 2, or negative 1. Hey, that tells us then that b equals positive 3, so we have one value. Likewise, I think the other value that would make sense to use would be x equals negative 2. So then if we plug that in, we'll have negative 2 on the left. Again, on the right side, negative 2 plus 3 is 1, so we'll have 1a. The b terms cancel out. So now we know that a is simply equal to negative 2. So I need to plug that back in. I know now a is negative 2. I know that b has value positive 3. And now, again, what I'm going to do instead of integrating this original thing, so it says instead of integrating x over x squared plus 5x plus 6 dx, instead what we can do is integrate negative 2 over x plus 2 plus 3 over x plus 3 quantity dx. Well, if we integrate this, we'll simply get negative 2, the natural logarithm of the absolute value x plus 2 plus 3 times the natural logarithm of x plus 3 plus c. So here we're going to use our properties of logarithms as well. I'm going to, remember our coefficients can go upstairs as exponents. So whatever the coefficient is, we can put that up as a power. We can put that up as a power. So I'm actually going to do a couple things first. I'm going to rewrite this as 3 times the natural logarithm of the absolute value of x plus 3, and then I'm going to write my minus 2 natural logarithm of x plus 2, just to basically rearrange it and make it look like one of their solutions. So so this is where I'm going to do the trick where the coefficients go up as exponents. So I'll have the natural logarithm of the absolute value of x plus 3, quantity cubed. I'm going to leave the minus sign in the middle and make that the natural logarithm of x plus 2 quantity squared plus c. And remember, lastly, there's this property of logarithms that if you're subtracting two logarithms, you can simply turn that into division as long as they're the same base, which we have here because it's base e or the natural log. So on top we have x plus 3 quantity cubed. In the denominator, we'll get our x plus 2 quantity squared. All that should be inside of absolute value plus c. And hey, there's our answer to that question. So kind of a long little tedious question for sure. Let's see. Let's do one other one here. So numero 6 is a lot better to me. It says simply find the derivative of x squared times sine squared x. Okay, so it's going to be a little tedious again. The first thing I'm going to do is just simply rewrite this. So we're finding the derivative of x squared. The other function, I can write sine squared of x as sine x quantity squared. So that's an equivalent way of writing it, and I like to see it this way just because it reminds me again to use the chain rule. So here we're going to have to use both the product rule and the chain rule. So if we take the derivative of the x squared part, if we do that, we'll just get, well, 2x. Let's leave the sine x quantity squared alone. Plus in the product rule, we'll leave the x squared term alone. And now if I take the derivative of the sine x squared term, well, the 2 comes out front. We have to leave the inside alone. Take 1 away from the exponent, multiply by the derivative of the inside, which is just going to be positive cosine. It doesn't really look like there's too much else to do on this one. They simply rewrite this. So they rewrite it again as sine squared x. And then it looks like, okay, maybe a couple of things here. So let's see, we have 2x squared sine x cosine x. So let's see, what we could do at this point is, so I'm not seeing that as one of their solutions here just yet. So this is the fun part of the multiple choice part is, I mean, definitely this is your, this is correct, but it's not looking like any of their A, B, or C. It looks to me like the closest one that they do, and this is certainly going to be okay. So a little trig identity. I'm going to pull the x squared out front, and then we have 2 sine x cosine x. I don't know what I just said, 2 sine x cosine x. And remember, there's a trig identity for 2 sine x cosine x, and it says that that is simply sine of 2x. And this is, in fact, one of their answers. So they write it as 2x sine squared x plus x squared times sine of 2x. So, all right, a little tricky. The derivative wasn't too bad, chain rule, product rule, but you definitely illustrating that you need to know your trig identities on these problems, because otherwise, again, you can do everything correctly, and it's just not going to look like one of their multiple